in today's lesson, we're going to be talking about a couple different things, but we're going to be focusing around slope. So slope, another word for slope is rate of change, okay? So we can think about this as slope, okay? Rate of change though, let's think about it in this way as rise over run, okay? So rise over run. So if I'm rising, I know it sounds like we're going up, but we can either go up or down. Running, we're going to go left or right. And this is on when we have a graph. So if we're given a graph, on the graph, to get from one point to the next, we can rise, which means going up or down, and then we can run, which means going left or right, okay? So those two are equal. That means the same thing. We're going to talk about that when we see a graph in just a minute, but let's go over this. So on a linear graph, this is called the slope of the line. So just like I said above, rate of change is the same thing as slope. So if you're given a graph, the rate of change or the slope, you find that by doing rise over run. Okay, which means you go up or down over you going left or right. Okay, so slope is written as a ratio. Now ratio is the same thing as a fraction. So slope is written as a fraction. So look up here really quick. You see how this is written as a fraction? Like if I wrote, don't write this. If I wrote 5 over, I don't know, -2, do you agree that 5 over -2 is a fraction? Yeah, right? So that's a ratio. It's also called a ratio. So slope is written as a ratio or a fraction of the vertical change, which we called rise above, right, to the horizontal change, which is run. Now, isn't vertical change up or down? Think about it this way. Which way is vertical? Vertical is up or down, isn't it? Isn't that line a vertical line? So a slope is written as the rise, which is the vertical change, up or down, to the horizontal change or the run, which is this way, left or right. Okay, I'm going to draw that a little straighter. Okay, so this remains constant or the same. This remains constant or the same for any 2 points on the same line. So the slope's not going to change. If you're given a line, the slope's going to stay the same the entire time. So slope is written as a fraction, just like we said. Remember, ratio is the same thing as fraction in simplest form. What does it mean to be in simplest form? It means we have to reduce our fraction. So if we have 6 over 8, that's not simplest form. What can we divide the top and bottom by? We can divide each of those numbers by 2, right? So if we divide them by 2, the simplest form is going to be 3/4. That's what that means. So slope is written as a fraction in simplest form. Okay, the variable we're going to use for slope is m. All right. So if I say find m, so look how many different ways we can say slope. If I said find the rate of change, we're doing this. So look at the screen, we're doing this. We're rise over run. Like if we're given a graph and I say find the rate of change. If I say find the slope and I give you a graph, we're doing this. If I say find m, right, it says the variable for slope, we're finding the slope, which means we're doing this. We're going rise over run. Okay, so I could ask you in a lot of different ways, and you see it written in a lot of different ways in different classes, okay? Now before we go on to an example, let's talk about the types of slope. So there's 4 different types of slope. We can have a positive slope, positive. Guess what the next one's going to be? Negative. It's just going in the opposite direction. We can have a 0 slope, which looks like this. And we can have undefined slope, which looks like this. So this is how I like to remember. This is how I like to think about it, because this is how you can remember it. Okay, let's go over to the positive slope first. If you picture someone walking, like let's say this is you right here, this red guy, that's you. You're walking up the hill. Do you see how you be walking up a positive slope? This is something that, so if it's positive, you're going to be walking up, right? So that makes sense that this line is positive. Well, let's draw that same guy. This is you now, going down the slope. Maybe you're on a skateboard. There you go. Or a snowboard. It's the best I can do. So there's negative, right? You're going down the slope. Or you're going down the hill on your skateboard, okay? So that's negative. Now 0. That's just like walking from class to class. Here's you, right? Walking from class to class. You're not going up or down. Well, I guess unless you use the stairs. But let's just say you went from my room, I don't know, down the hall, right? To get a drink of water. You're not going to go up the stairs. It's 0 slope, right? It's not up or down. Okay, undefined. Now, if you're standing here on the top and you jump off, what's going to happen to you? You're undefined, right? You don't want to do that. You're jumping off a hill. So this is how you can remember that. Undefined. Undefined, slope looks like a straight line up and down. It's a vertical line. Do you remember what this line is called? Right here? This line is horizontal, right? Didn't we talk about that up here too? This line right here, if you look at the screen, this line, this is a horizontal line. This is a vertical line. This is a vertical line. So when you're given a vertical line, it's undefined slope. When you're given a straight line, it's 0 slope. I guess every line is straight, but what I mean is when you're given a line that looks like this, it's 0 slope. Okay, let's go on to a couple examples. It says find the slope of each line. Now look what it says over here, over there. It says m equals. Remember, what is m? M is what? M is the slope. Don't forget, remember, didn't we say up here the variable for slope is m? So if it's saying m equals, it's saying the slope equals. Now, what did we talk about at the very beginning? Slope was rise over run. Slope was rise over run. Okay. So now from there, let's look at our graph. So we're going to start. It actually gives you a point to start here. See how it's like a dot right there? But do you see how where it intersects? You see how it intersects? That like cross right there, that plus sign in the middle of it? This is where we're going to start. Now, where else on this line do you see it crossing? Not here, not here, not here, not here. Where do you see it again? All the way, not until up here. So we're going to start at this point right here. And we're going to rise until we get to the same height as this point. So let's go up. 1, 2, 3, 4, 5, 6, 7. So we're going up 7. So m equals. Now remember, we either rise. When we rise, we're either going up or down. Did we go up or did we go down in that case? We went up. So it's going to be a positive 7. Over. Remember, this is always written as a ratio or as a fraction. Now, from this point that we got up here, how many do we have to move to the right to get to our next point? 1, 2, 3, 4. We're going to the right. So that means we're going in the positive direction. So it's over positive 4. And that's your answer. That's your slope. Is it in simplest form? Yes, because we can't reduce that fraction. Okay, what about this next one? So here, we can start here or we can start here. It doesn't matter where you start. You're gonna get the same answer. Let me show you what I mean. Okay, if I wanna go, where am I gonna go down until? Well, if I go down until here, do you see how I'm too far down now? I need to match that point over there. So that's how I know when to stop. So I'm going to go down here, that many units, and then I'm going to go across until I hit that point. Okay? So how many am I going to go down from this point? Well, 1, 2, 3. Now I'm going down 3. What does down 3 look like? That's going to be a negative 3. Okay? And then I'm going to go from here, I'm going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, over 9. and I went in a positive direction. I went to the right, so I'm going to do positive 9. Now, what if instead I started from the bottom point, because I started from the top point? What if I started here and I wanted to go up here? This time, it's going to look like this, but watch, we get the same answer. How many am I going up here? 1, 2, 3. This time I'm going up 3. So that's a positive 3 over. Now which way am I going? 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm going left 9 this time. So this time it's going to be over negative 9. Well, both of those are the same answer. Negative 3 over 9 and 3 over negative 9, both of those are the same thing. Both of those can be written like this as well. When you're given a fraction, it doesn't matter where the negative goes, top or bottom, doesn't matter. That just means that whole fraction is a negative, okay? So can we reduce this though? We can actually reduce it because both numbers go into a 3. So if I divide this by 3 and divide this by 3, I'm going to get 1 over negative 3. That is my slope. That is my answer. Okay, let's try number 3. Okay, now look at this. This is the line. What does it tell us up here? What kind of slope is that? It's 0, isn't it? This one right here. So let's write 0 slope. That's all we have to write for that. That's easy. Cool, done with that. You can also write it like this. 0 looks like that, right? M equals 0. So this has a 0 slope. Now, what about this one? Remember our little guy up here? If he falls off, what happens to him? He's undefined. So this one you just have to write undefined, and you're good there. Okay. All right, let's go on to number 5. So we're going to start here, and we're trying to get all the way up to here. So we have to go up 1, 2, 3, 4, 5. And we went up, right? So it's a positive 5. And then we have to run 1, 2, 3. And we went right, so it's a positive 3. So remember, slope is rise over run. So we rise positive 5. We ran positive 3. That's your answer. Okay, let's try the next one. Number 6. Okay. Also, let's look at this really quick. Is this a positive slope or a negative slope? If I drew my guy right here, this is you. Are you walking up or down? You're walking up, right? What should this be then? Should that be a positive or a negative? Shouldn't that number be a positive if we're walking up? Because this is a positive slope right here. It's a positive slope, right? So it should be a positive number. Now let's think of this. Should this be a positive or a negative slope? Well, if we're riding a skateboard, we're going down, and we're going down quick, right? Because this is really steep. So let's try this one. So now so we know it should be a negative. So let's keep that in mind. Okay, our slope should be negative. How do we get from this point to this point? Well, let's go down 3. So we're going down 3. That's a negative. Now we're going over a positive 1. So what's our slope? Negative 3 over 1. Okay, negative 3 over 1. Now anything over 1 is just itself on the top, right? So my slope is negative 3. Was it negative when we went down on a skateboard? Yeah, we went down the slope, so it should be a negative number. So let's think this one. Should this be positive or negative when we're finished? Well, if we think about walking again, it should be a positive, right? So keep that in mind. That's going to help you. Okay, we're going to go up. 1, 2, 3, 4. We're going to go over 2. We went positives in both directions. Don't forget to simplify. What's 4 divided by 2? That's 2, right? So our slope is 2. Okay, should this one be positive or a negative? Let's remember that this one should be a negative. It's a negative slope. So let's start here. We're going to go down to our next point. 1, 2, 3, 4. We're going down, so negative, down 4. How many were we going over? 1, 2, 3, 4. We're going over a positive 4. So our slope is negative 4 over positive 4. And what's negative 4 over positive 4? Well, a negative divided by a positive is a negative, right? And the 4 over 4 is just 1. Don't say 0, okay? This equals 0. This equals 0. This equals 0. Do you see the pattern? If a 0 is on top, the whole fraction is 0. If you put in your calculator right now, if you wanted to see what's negative 4 divided by 4, it is always, whenever you have a number over itself, that equals 1. Okay? It's negative 1 in this case because you have a negative here on the outside. All right. Almost finished with this page because I want you guys to try 11 through 14 on your own and then show me. So let's just try 9 and 10 and then I'll let you guys try that. Okay, trying to get from here to here. We're going to go down. 1, 2, 3. If it's down, it's a negative, right? Now we're going over 1, 2, 3, 4, and we went over a positive. Remember, slope is always rise over run. So we're rising a negative 3. Remember I said at the very beginning, rise can be up or down, and run is either going left or right. So here we're rising down. We're going down, right? So it's a negative 3. And then we're running to the right. So it's a positive 4. And it should be negative, shouldn't it? If we are on a skateboard, aren't we going downhill? Same thing here. Now here, if you're going on a skateboard, you could really hurt yourself because this looks super steep, right? This is like really, really steep on a skateboard or a snowboard, right? So it's like the black diamond if you go snowboarding. So here, from here to here, we're going to go down. It's going to be a negative. We know that, right? So we're going to go down 1, 2, 3, 4, 5. And we're going to go over 1. What is a negative 5 over 1? It's just itself on the top. Anything over 1 is itself. So like negative 5 over 1 is negative 5. Now, I want you guys to try 11, 12, 13, 14. You try. Try those. When you're finished with the notes, come up to me. I want you to show me 11 through 14 and then a couple more on the next page. Okay? So here we talked about slope, right? We talked about slope when we're given a graph. We talked about slope when we're given a graph. So all of these had a graph, right? We just did rise over run. We figured out the slope. What if we weren't given a graph? Then we use the slope formula. So for these six, we're going to use the slope formula to find the slope between the 2 points. Notice here, we don't have a graph. Here we did. Here we don't. So this is the formula. So it says the slope formula is used to find the slope between 2 points. And then it gives 2 points, and it has that little 1 at the bottom. So watch this. y2 minus y1 over x2 minus x1. Don't be afraid of those little 1s at the bottom and 2s at the bottom. All that means is your second y minus your first y. See here? Oops. Right here. Second y minus your first y over your second x minus your first x. And if you're still like, what the heck does that mean? I'm going to label these for you, okay? So when you're given 2 points, this is really important. If I give you 2 points, whenever you're given 2 points, the first thing you do is find the slope. So let's say that. Whenever you're given, because later on in this unit, I'm going to be giving you 2 points and ask you to do something, and you have to know right away, the first thing you do is find the slope. So without me even asking, I'm not going to say find the slope. You're going to have to get even deeper into it. You're going to have to dive even deeper into it. So if I say, okay, here's 2 points, and I'm going to tell you to find a line, right, that matches those 2 points. Don't worry, we're not there yet. But you have to know first, you have to find the slope. So whenever you're given 2 points, find the slope first. Okay, so we're given 2 points. It actually asks us to find the slope. Now, here's what we do. We're going to use this formula, and I'm going to label each point. This is the first point they give me, correct? And this is the second point they give me, right? So everyone understands that. I'm going to label this my x1, and I'm going to label this my y1. Isn't every point x comma y? Every single point is x comma y. So this is just x1 comma y1. All that means is it's the first x and y point. What do you think this one's going to be? X what? X2 and y2. That just means it's my second point, and x always comes before y. That's all that means. Okay, now we're going to use this formula, and we're going to plug it in. Okay, so we have y2 minus y1. I'm going to rewrite it so you can see y2 minus y1 over x2 minus x1. So what are we finding here? We're finding the slope. This is like the rise over run, but we can't do rise over run because we do not have a graph. So this is how we find the slope. So what's my y2 here? My y2, isn't my y2 this right here? Didn't I label 3 y2? So I'm going to plug in 3 for y2 minus, right? That's part of the formula, 3 minus. Now what's my y1? Y1 is 1, isn't it? So minus 1 over, what's my x2? This is my x2. This is my x1, right? So 4 minus 1, x2 minus x1. That's just 3 minus 1 is 2. 4 minus 1 is 3. That's it. That's my slope. If it was a graph, for example, let's think about this. Would that be a positive or a negative slope? Positive, right? It has a positive sign, so it's going to be positive. If that was like on a graph somewhere, it would probably look something like this, right? It would be like up 2 over 3, something like that. So that's kind of like what it would look like. You don't have to draw it, but I'm just showing you. If those points were drawn and we drew a line between them, that's what it would look like, something like that. Okay. Negative 2, 4. So I'm going to label again. This is my first x, this is my first y, this is my second x, and this is my second y. Then I'm just going to plug it into the formula. Okay. So what's my y2? My y2 is negative 2. This piece, isn't it? It's negative 2. So I have negative 2 minus, what's my y1? 4. So minus 4 over x2, which is 10, minus is part of the formula. Now, look here. This is really important. This is where a lot of people make mistakes. You see how my x1 is negative? That means because this negative is part of the formula, right? I did x2. What was my x2? 10. x2 minus my x1, but my x1 is a negative 2, so be careful. I have to write it like this, right? Now, watch what happens here. Doesn't that turn into a positive when we have 2 negatives right next to each other? 10 minus negative 2 is really the same thing as 10 plus 2. So negative 6 over 12. Okay, what's negative 6 over 12? Can we simplify that at all? We can divide each top and bottom by a 6, can't we? Does it go in? Yeah, what's negative 6 divided by 6? Negative 1. What's 12 divided by 6? 2. So my slope is negative 1/2. Okay, negative 1/2. Let's try the next two, and then I want you to do 5 and 6 on your own. So, okay, actually, no, never mind. I was going to say something crazy is going to happen on this one, but it's not yet. Okay. Whoa. Okay, m equals y2 I forgot to label. So let's label. You don't have to label, but I think it's easier. So there's a lot of mistakes that can happen. Easy mistakes, even if you understand the whole thing if you don't label. So make sure to label. What's my y2? My y2 is negative 5 minus my y1. My y1 is 5. x2 minus, here we go again, minus x1. x1 is a negative, so it's minus negative 4. So negative 10. Remember, negative 5 minus 5 is not 0. It's negative 10. Okay, now this whole thing, this turns into a plus. Negative 8 plus 4. Two different signs you subtract and keep the sign of the bigger. What's a negative divided by a negative? Isn't that a positive? So it's going to be positive. Positive. Now, can we simplify 10 over 4? What can we divide each top and bottom by? Don't they both go into a 2? So we could say 5 over 2. And that's your final answer. That's your slope. Remember, again, we're finding slope. Darn, I just realized. Okay, you know what? You try this one on your own. You're going to try 4 on your own. I'm going to do 5 and 6. Okay? So, again, label. y2 minus y1 over x2 minus x1. Okay, what's happening here? So 3 minus 5 is negative 2, right? But 9 minus 9 is 0. If you put that in your calculator, 0 divided by negative 2. Anytime a 0 is on the top of your fraction, the whole fraction, no matter what's on the bottom, equals 0. Okay? If a 0 is on top, now a 0 cannot be on the bottom. We're going to talk about that in a minute. But if a 0 is on top, and you have any number besides a 0 on the bottom, so like here we had a negative 2, it always equals 0. Okay, that's it. Your slope is 0. What does that look like on a graph? Didn't we talk about it this way? When we have a 0 slope, it would look like this, wouldn't it? And like this, right? Isn't that a 0 slope? So that's what we're finding here. Between 2 points, we're finding the same thing. We're just saying, okay, the slope between those 2 points is 0. Now what about this one? y2. Let's label again. Okay. y2 minus y1 over, now try x2 minus x1. So x2 is negative 7, isn't it? Minus x1. This piece is your x1, so we're doing x2 minus x1. Remember, there's a negative in between. So this is going to be negative 3 over. Now here, this turns into a plus again. What's negative 7 plus 7? 0. Now what did I just say? The 0, if it's on top, up here, look to the left. So look at the screen. Oops. If this 0 is on top, it equals 0. If 0 is on the bottom, it's undefined. Put that in your calculator. See what happens. Do negative 3 divided by 0. It'll say error. That's because it's undefined, right? That looks like this. This is this kind of graph where your person's standing on top and they jump off and they're undefined on the ground. Right there. That's undefined. That's when mathematically, when we write it out as when we're finding the slope, that means on the bottom there's a 0. Okay? Okay. Last thing, I know this is kind of long, but it's not too bad. So I wanted to try to get all this in at once because I think most of you have done this before. Okay, let's try it. This is really important, you guys. Please, please pay attention to this. When you get into Algebra 2, not geometry really, but Algebra 2, oh my gosh, we use this so much. So please pay attention. Linear equations are frequently written in slope-intercept form. So this right here, slope-intercept form, that's what we're talking about in these notes, okay? This is how you write an equation in slope-intercept. Also, what is a linear equation? What does it mean to be linear? This is what it means. Actually, Here's examples all the way down here. Do you see how all of these examples, all of these lines, all of these graphs have lines? They're just straight lines, right? That's what it means to be linear. Linear means straight line, okay? So linear equations, or equations that are straight lines, are frequently written in this form. This is really important. Do you remember what we said m was? Remember what we said m was? Didn't we say m is the variable for what? For your slope, right? So let's look here. M is the, what do you think? Slope. Okay, B. So that means that this piece, that's your slope. That's going to be a number. Okay? B, this B, that's your y-intercept. What the heck is a y-intercept? We're going to figure that out in just a second. Okay? Now, let's think about what a y-intercept would look like. This is the y line, isn't it? What do you think that the y-intercept, where does it intercept, or where does it touch the y-intercept, or the y-axis? Where does it touch the y-axis? Doesn't it, this line touch the y-axis right there? That is your y-intercept, okay? That's your B. So, M is a slope. Cool, we already did that. We just talked about that in the last 2 sections. But B is your y-intercept, okay? Let's get into some math. So given the slope and y-intercept of the line, slope is your M, y-intercept is your B. Write the equation in slope-intercept form. What slope-intercept form? Oh, slope-intercept form is this, okay? I have to write it in slope-intercept form. Now, watch this for number 1. It says slope is 2. If I wrote it in y equals mx plus b, which one's my slope? Look over here. Which one's my slope? It's m, right? So this is what I'm going to do. I'm going to erase this. You don't have to do this normally, but I'm just going to show you. This is us plugging it in. We're plugging in 2 for our slope. What's my y-intercept? My y-intercept is a -1. So I'm going to erase the b, and I'm going to put in -1. That's your answer. That's all you have to do. Y equals 2x minus 1. Okay, so what about this next one? Y equals mx plus b. What's my m? What's my slope? My slope here, it says, is -3/5. I'm going to put an x outside always. Your slope always gets an x next to it. And then I'm going to put plus b, plus my y-intercept. What's my y-intercept? A +4. That's it. Cool. Let's try this one. Y equals, what's my slope? Mx. My slope is -3. So I'm going to plug that in for m. Plus b, plus my y-intercept. Okay, I want you to try 4, 5, and 6 on your own. Same thing. You're just going to write it in slope-intercept form. So if I ask you to write something in slope-intercept form, this is how it's going to look. What 2 pieces of information do you need for slope-intercept form? Well, you need a slope and you need a y-intercept, right? Just the slope and the y-intercept. Oops. Okay. All right, let's try number 7. So identify the slope and y-intercept of the line on the graph. Then write the equation of the line in slope-intercept form. Okay? So it says first to identify the slope and y-intercept. What's the slope here? Didn't we just do that on the other one? We started here, right? And we went up to here, and we went up 1, 2, 3, over, and then to get to this point, I go over 1, don't I? Is this going to be a positive slope or a negative slope? Well, if I draw my little guy here, if this is you, are you walking up the hill or skateboarding down? You're walking up, right? So it's going to be a positive slope. So instead of writing 3 over 1, I'm just going to write 3. So my slope here is 3. What's my y-intercept? Where does it intercept the y-axis? Well, if I go down, 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 doesn't it hit it right there? At this point? What point is that? So I'm going to start at 0, 0. I'm going to go down. 1, 2, 3, 4. It's a -4. Well, perfect. Isn't that, oops, oh my gosh, I'm erasing everything. Okay, isn't that all I need to write my equation? Y equals mx plus b. Y equals mx plus b. Now this time it's not, don't write plus negative, it's just -4. Okay, -4. You guys with me? So try this next one. Am I going to have a positive slope or a negative slope here? Well, I'm writing down on my skateboard now, right? So I'm going to have a negative. So I'm just going to write that negative because I know it's going to be a negative. Now I'm going to go down how many? 1, 2, 3, 4, 5, 6. Down 6. That was a -6. Over how many? 1, 2, 3, 4. Cool. Can I reduce that? Can I simplify that? Yeah, I can actually divide each of these by 2, can't I? So this is a 3 over 2, and it's still negative. Don't forget about that. So I'm going to erase this whole thing, and I'm just going to, it looks confusing. I'm just going to write -3 over 2. Okay, what's my y-intercept? Where does it hit the y-axis? Well, if I look at my y line, this is my y line. Where does the line hit it? It hits it right here. So from my origin, from my 0, 0, I'm going to figure out what that is for my y-intercept. 1, 2, 3, 4, 5, 6, 7. So positive 7. So y equals mx plus b. All right, I'm going to do these next two, and then I want you to do 11, 12, 13, and 14, okay? So here. Now, here doesn't ask, but we need those two pieces, don't we? So I'm going to write off to the side. There's not really any room. I'm going to write m equals and b equals here. What is my m? What is my slope? So 2 over 1, 2, 3, 4, 5, 2/5. Where does it intercept the x-axis, or the y-axis? What's my y-intercept? So if I look here on this y line, doesn't it hit right here? And this is 0, 0, right? So my y-intercept is -3. So if we're going to write an equation, y equals mx. Remember, don't write plus negative. If it's a -3 for the y-intercept, just write -3. Right, last one, and then you can try a couple on your own. So slope, let's see from here, is it going to be positive or a negative? It's going to be positive, isn't it? It's a positive line. We're walking up the hill again. So 1, 2, 3, 4, 5, and we're going to run 1, 2, 3, 4, 5. Okay, what's 5 over 5 equal? Just 1. Remember, a number divided by itself is always 1. And if I look here on my y-axis, where does my line hit? It's right here. So let's figure out what that number is. 1, 2, 3, 4, 5, 6. It's a -6. Anything down here for the y is a negative, right? Below the origin. So let's write my equation. Y equals 1x minus 6. My m is 1 and my b is 6, -6. You can also write it like this. Those are the same thing. Oh, you don't need to put a 1 in front of the x. If there's an x there, or if there's a 1x, that means 1x. There's only 1x there, right? There's not 2 x's or anything like that. So this is your final answer. Okay? Try numbers 11 through 14 and show me before you, so try actually 4 through 6 and then 11 through 14. And then all the other ones that I circled. So number 4 on this page and then 11 through 14 on this page, okay? And then come up and show me when you're finished.